Lesson 2, graphing linear inequalities. Again, only curve that they're going to throw at you today is that these equations are not going to be in slope-intercept form. So you'll have to convert them to slope-intercept form. So this step will apply today. You will have to multiply or divide by a negative number, which means you will have to reverse or flip your inequality sign. If you don't do that, your graph and shading will be off. You still follow the same 3 steps, step 1, 2, and 3, as we did yesterday. Put it in slope-intercept form, determine what type of boundary line is it, and where the shading belongs. So here's our first couple of examples. Notice in example 1 we have x plus 4y is greater than 8. It is not in slope-intercept form, so that's the first step that we'll want to take, is go ahead and put this into slope-intercept form. So we need to get y by itself. In order to do that, I need to get rid of x. So I would subtract x from both sides, and I now have 4y is greater than negative x plus 8. This is a negative x, this is a positive 8. Now we need to get y by itself. In order to get y alone, I need to divide both sides by 4. So I divide by 4. Inequality sign is going to stay the same because I'm dividing by a positive 4. Now I would basically wind up with here is y is greater than, well, really this is a negative 1x, so I'd have negative 1 over 4. That would be next to x. And then I have an 8, positive 8 over 4. This here reduces. So I'd have y is greater than negative 1/4 x, and then I have 8 over 4. That would reduce to 2. So this would be my equation in slope-intercept form. So that's what we'll use above here. Your slope being negative 1/4, your intercept being 2. So on my graph, my intercept is 2. So I'm going to go ahead and plot 2. My slope is negative 1/4. So this line should decrease. So I can go ahead and use negative 1/4. So I'm going to go up 1 over 4, make sure my line decreases. Or from my y-intercept, I could go down 1 over 4. Still decreasing. Now that it is in slope-intercept form and that we've plotted our points, there's that equation in slope-intercept form, we look at this to determine our boundary line. This is a greater than symbol. Greater than has a dotted line. So here's my dotted line through my points. And the last step, I also look at that being in slope-intercept form. That is a greater than symbol. A greater than symbol means that I would shade above the boundary line. So here's my shading above the boundary line. Or you could use your test point, 0, 0. When I put in 0, 0, I put in 0 for y and 0 for x, I wind up with 0 is greater than positive 2. So here's your test point. 0 is not greater than 2, so I wouldn't shade that area. I'd shade the opposite side. Example 2, same scenario, not in slope-intercept form, so we need to convert to slope-intercept form. So we'll go ahead and do that right here. We have 2x minus 3y is greater than or equal to 0. Need to get y by itself, so I'm going to subtract 2x from both sides. I have negative 3y that I would drop down, which is greater than or equal to. I have negative 2x, and then I don't need to put plus 0. I'm not going to gain anything by adding 0. So I need to go ahead and get y by itself. So here I would divide by negative 3. I've just divided both sides by a negative number. When that happens, remember you need to reverse or flip your inequality sign. So I now have y is less than or equal to, and we have a negative divided by a negative, that's a positive, and this is simply a fraction, 2 divided by 3, which is 2/3, and we'll write it next to x. That can't be simplified. So there is no intercept here. Now we have this equation that we can go ahead and graph with. So our equation, y equals, actually I should say y is less than or equal to 2/3 x. I'm going to go ahead and pull out my intercept being 0. So I'll plot my intercept, 0. I'll use my slope, which is 2/3, and this line is increasing, so I'll go up 2 over 3, plot, up 2 over 3, plot, or I could go from my y-intercept, I could go down 2 over 3 and plot. So I have a bunch of plots on my paper. I look at my sign. This is a less than or equal to, which means it is a solid line. Also looking at my sign, this here being in slope-intercept form, when I look at my sign, it is a less than or equal to. A less than or equal to means below the boundary, so I would shade below the boundary here. If I were to use a test point, notice I can't use 0, 0 because that's on the line. So I'd have to choose a new test point if I like the test point method. Maybe I choose this point that's above the line, and that point would be 0, 2. So I'd plug in 0, 2 in the appropriate spot there for my equation. And if I did that, notice the first one is my x value, so I'd put in 0 here and 2 here. So I'd wind up with 2 is less than or equal to 0, and 2 is not less than 0. So again, that's just proving you that above the boundary line is not a solution. Home stretch, we have 2 equations left. I would like you to go ahead and pause the video and work through this third example here. Get that in slope-intercept form, graph it, determine your boundary line, and do your shading. So go ahead and pause the video and work through it. Put it in slope-intercept form. First thing that we should have done is subtracted x from both sides. And we're still not finished. We still have a negative y there, so we need to get rid of that negative sign. So remember, this is really a -1, so we can divide both sides by -1. Since you've divided by a negative number, your inequality switches or flips. So we have y is greater than or equal to. We have a -1 divided by a -1. That is a positive 1x, or we can just write it as x. We have a -2 divided by a -1. That would be a positive 2. So there it is in slope-intercept form. Next, you should go ahead and graph. Slope is 1 or 1 over 1, intercept 2. Look at our boundary line, greater than or equal to, which means we have a solid line. In slope-intercept form, greater than or equal to means it is above the boundary line, so everything up here would be the shading. And again, if you wanted to, you could use test point. Notice your test point 0, 0 is open, so you could have chose that method as well. Last example here, we have y is greater than 4. Remember, this is telling you that it crosses the y-axis at 4. When you have a variable and a number, it's telling you where it's crossing. So we're crossing our y-axis at 4. There it is. We're crossing the y-axis at 4. We look at our sign. It is greater than. Greater than means we have a dotted line. So here's our dotted line. That's where it's crossing the y-axis at 4. Again, you look at it. This is in slope-intercept form here. We have our variable. This is a greater than sign, so that is telling us that it is above the boundary line. So here it would be above the boundary line. Another thing you could do is your test point again. You could use this test point 0, 0, so I'd put 0 in for y. There is no x, and we know that 0 is not greater than 4. That is not a true solution. So again, we'd shade above the boundary line. This will conclude Lesson 2, Inequalities.